Hello, I'm Kat. I am a developer at Brightpool, based in Bristol here. And I've been doing PHP for over 5 years now, and about a year ago I picked up Go as my second language that I use day to day at work. So in this talk I wanted to give you an idea of what Go is and how it compares to PHP. And you might be wondering, like, what the hell, Kat? This is a PHP meetup. What are you doing here with a Go talk? Yes, it is a PHP meetup. You are in the right place. But I think that as developers, you should always try and learn new languages and new frameworks and new tools, because it's just like with DIY. Like, you wouldn't just do everything with one tool. Like, you wouldn't try and put a screw in with a hammer or something. Like, it might work, but it's not the right tool for the job. And the only way to learn how to pick the right tool for the job is to know as many tools as you can possibly learn. So hopefully this talk will illustrate why it's very, very important for developers to always look out for new ideas, new languages, new frameworks, new things to learn. So let's start with the basics. What's Go? Go is a language developed at Google. I was really shocked because when I found out that it's going to be 10 years old this year in November, most people think, and I was one of those people who thought Go was fairly new, like, maybe 5 years old, maybe 3 years old. It's gonna be 10 years old this year. It was made by these three chaps, and two of them, Rob Pike and Ken Thompson, are sort of really big names in the computing and the programming world. So, yeah. And then the official logo is a little gopher, so you'll see a bunch of those throughout the slides. The main difference is obviously the mascots, right? So if you want to learn Go, you're going to have to make some space for the gophers in different colors. That's the biggest difference, but no, seriously. So I picked those three things to talk about tonight. There's obviously a bunch more differences, but those are the things that kind of stood out to me as sort of the biggest differences between PHP and Go. And that's obviously the syntax, but it's quite funny. The support for concurrency, which is built into Go, and how you run the PHP apps versus how you run Go apps. So very quickly about syntax, it does get quite funny switching from PHP to Go because the type declarations are the other way around in Go. So in PHP you do, which way around you do it? You do type and param, and then in Go you do param and type, and it leads to some funny things like this one where you switch from PHP to Go and you start writing PHP in Go, and then you do Go for a bit, and then you go back to PHP and you start writing Go in PHP. It's quite funny. There are no semicolons at all in Go. It's not like JavaScript that you can or cannot put them. There's just no semicolons. And Go is very, very strict about its formatting rules, a lot stricter than PHP. Like in PHP, you can spend half a day arguing with somebody, oh, do we put the curly braces on the same line as the function or on the new line? Or do we use tabs or do we use spaces or do we do this and that? And Go basically said, nope, we're going to have one standard way of formatting your code. And that's it, like, take it or leave it. So you still have some flexibility. You can still, it's not as bad as it sounds because you can still write the code the way you want. And then there is a tool called Go Formatter, which is pretty much standard in all the major IDEs that will run through it every time you save a file and format it the Go way. So even do things like convert your spaces to tabs because Go prefers tabs. But the huge benefit of that is that, like, initially might put some people off, especially if it's a different style to what you use. But in the long run, the huge benefit is that all the Go code across GitHub looks exactly the same if it's been through a Go formatter, which is kind of a standard thing to do, which means it's very easy to read other people's code. And you basically save hours not arguing about tabs versus spaces or brackets on which line and whatnot. So let's look at some Go. Enough of me describing it. This is a very simple hello world example. We've got a package declaration at the top, which is kind of like a namespace in PHP. Some import statements for which libraries you want to use. And again, there is a tool for that in Go that populates this automatically, so you don't have to do it yourself. And then the main function, there's two ways of declaring variables. Line 6, which is this line, you basically do the lengthy way of doing var, variable name, type, equals value. You could omit the string in here because Go can work out that you're trying to declare a string, so you don't need to actually specify that this is a string. If I put true in here, it will know that this is a Boolean. And Go is a statically typed language, so it's got types. You cannot change the type of a variable throughout the execution. And then line 8 is a different shortcut way of declaring a variable, and that's kind of what you find yourself doing most of the time, which is just variable colon equals value done. Very simple. Kind of feels a little bit cleaner than PHP without the semicolons, and you notice that there is no public private as well. Go replace that with a simple convention that if the name of something, a function or a variable, is capital, then that function or variable is visible outside of the package, and then if it's lowercase, it's only visible inside the package. So that's kind of your public-private equivalent in Go, only it's just done with casing. So there's less boilerplate code. And then there's a simple printf statement, which I'm sure you can work out what it does. Now, how you run this, it's very simple. You can either do go run name of your file, and that will run through the file. It won't actually create the binary, because Go is a compiled language, which means that every time you run, you have to compile it to your architecture. But you can just run, like, sort of compile it on the fly, and then it won't actually output the binary, which is the first thing that we're doing here. Or you can build the binary, which is you just swap run for build. And you can see here in the ls, we now have a binary called Lionel, and then we can run that, and the output is exactly the same. So running Go apps and compiling Go apps is as simple as Go build. This is probably the most intense slide. So basically, when I started doing Go, I was sort of reading around on the subject, and I came across a talk by Rob Pike, one of the authors of Go, saying that concurrency is not the same as parallelism. And I was like, ooh, how so? Because as PHP developers, we're kind of like, well, it's the same thing. And you don't really come across concurrency in PHP because you don't really deal with threads in PHP. Like, by design, it wasn't sort of designed with that in mind. Whereas with Go, we do. And then it's good to learn how to design concurrent Go apps well if you want to write concurrent apps. And to do that, you kind of have to look into some theory that helps you wrap your head around, like, some of the design problems that you might run into. So this is I'm not going to go into details because Rob's talk is excellent and you should go and watch it. And there is a link at the end of the slides, so I'll remind you about that. He does an excellent job explaining this in about 20 minutes. So I'll just give you a TLDR. Basically, this is a very simple example where we have a system with 8 gophers. And this is a concurrent design because each one of those gophers can do its job independently, right? One doesn't need to wait for another. So this is a simple example where they're burning books. So one of them is picking up books. One of them is like bringing them over. This is the incinerator. So one of them is loading the books in, and then the other one comes back with the empty trolley. So that whole system, they can all do their job concurrently. And that sort of concurrency is more about the design. And this design it can be parallel, but it may not be. And the difference is that parallelism is more a condition that something is parallel if at least 2 things run at the same time. And that literally just means at least 2 things running at the same time. So in this case, the design is concurrent. The app is designed to be concurrent. But if we only have one gopher doing their job, then it's not parallel because there's only one thing moving at the time. If all gophers run around, then that's concurrent and parallel. And then if you swap gophers for threads, then if you have all these threads running around, then you've got a concurrently designed app. But if you run a multi-threaded app on a single core processor, then that's not parallel because then you only have one core. So even though you have multiple threads, and it might seem like they're all doing the same things at the same time, it's only one core executing it. So it's not really parallel. If you take the same concurrent app and put it on a multi-core processor, then you are doing things in parallel because you might have every core operating a different thread. And why am I telling you all this? It is kind of important to realize the difference when you're designing Go apps if you really want to take advantage of the multi-core architecture that you might be running your apps on. So there is a little bit of theory involved, but that's probably the most intense slide for the rest of the talk. Yeah, do watch Rob's talk if you're interested because he actually gives more example, and this is actually a slide taken from his talk as well, so I completely stole the idea. So how does Go do concurrency? Actually, before we go into Go, you can do concurrency in PHP. There is a pthreads extension, which I think somebody talked about it at the PHP South Coast 2 years ago, or like one of the first ones. But even they said that nobody's really running p-threads in production. And I've never heard of any PHP developers doing multi-threaded PHP in production. So that's very rare, if it happens at all. Whereas Go has been designed from the ground up to support concurrency and to make it as easy as possible for developers to write concurrent programs. So Go is a little bit like C, except for it comes with the nice things. It gives you the nice things. It gives you garbage collection. It gives you memory management, so you don't need to worry about those things, which means that you can spin up Go routines really easily and not worry about allocating memory and all of that. And what is a Go routine? A Go routine, it's not necessarily a separate process. It's more like a separate thread of execution. So you've got the main thread of execution for your app, and then you can spin up separate threads that go off and do things, whatever they need to do. And that is essentially a Go routine. And then there is a second sort of part to it, is something called channels, which is basically a structure that Go introduced as a way of as a means of communications between two threads, because you might have two threads that might need to pass some information across, or you might have the main thread wanting to communicate to the child threads that, hey guys, wrap up because I'm about to exit or something. And Go routines essentially communicate with each other using channels. So when you look into Go, channels, Go routines, those are the two kind of main keywords that you're going to come across. These are still fairly simple examples just to illustrate kind of how we do concurrent programs. So at the top, you've got a simple function. It takes in a string, loops through the for loop 3 times, printing out the iteration number and that string, and then sleeps for a second every time it loops through. So in the main function, the first call, the one on line 17, that's just how you'd normally call a function, right? That's just standard, same as PHP, you just call f direct. And you can see in the output here on the left of yours, that we've got the first 3 things is direct 0, 1, 2, which is just that function. So this is still one thread. It's the main thread running through that loop 3 times. And then we're spinning up a Go routine here. And then right away, we're spinning up another one. And these two basically show you the different ways of sort of what you can do with Go routines. Because you can call a function, you can declare a function dynamically, you can sort of start a Go routine in a few different ways. But in every case, you use the Go keyword. It's just as simple as going Go, function name, done. You've got a new thread. So here we're spinning up two new Go routines. The first one is going to still do the same thing as the first call to the function. And then the second one is going to just print out a statement, sleep for 2 seconds, and then print out another statement. So here you can see that the sort of output of each one is overlapping because they do things at the same time. So the first one sort of started looping through the for loop, and then the second one, in the meantime, is printing that one, sleeping for 2 seconds, and sleeping here. Now, the output of this might be different every time, depending on sort of how quickly you go from this one to this one, for example. Here I've just like played around with the seconds nicely so that it does actually force it sort of like there's a good chance they will overlap the outputs. So yeah, there you go. That's just a simple app which does 2 things in 2 different threads and then comes back to the main one. It's just as simple as that. And then this is another example where we use channels. So in the main function, we create a channel. Channels are typed. So here we create a channel which accepts 1 Boolean. And then we spin up another Go routine to do some stuff for us. And then that last line on line 19, it basically means the main thread is going to wait until something arrives from the done channel. And then the worker function is going to print out working, sleep for a second, then print out done, and then return true on the channel. So the main function is not going to exit until the true is returned on the channel. And that's basically, that's how you can communicate between different, how the Go routines can communicate. Because this is a very simple example, but you can pass in whole structs, you can pass in whatever you want in the channels. So that's kind of the Go mechanism for synchronizing. And as well as that, Go supports things like mutexes and locks and other fancy stuff to kind of make sure that you do like thread safe applications and operations. So hopefully you can sort of work out that we can speed this up if you do this. And there are a ton of applications where you might, like we had at work, where the reason we started looking at Go is we had a gigantic script, which was a PHP like 2,000 line long script, which was processing incoming emails. It was just doing it sequentially, and it got to the point where it was running with like a backlog of 3,000 emails. It was just not coping very well. And then we said, well, hang on a minute, like there's so much memory left on that box, so much processor power like left on that box, and it's just churning through the emails really slowly. And then we sort of thought, why don't we use something like Go, where we can just process the emails in parallel? We can have like 5 different workers picking them up, and then it's going to use a bit more memory, which is completely fine, but it's going to go 5 or 10 times faster. And it really did. So we rewrote that PHP script in Go, and now it's doing something like 10.5K emails per day and not even breaking a sweat. So it was a really good decision on our side to kind of go into the concurrent design. A little bit about how running PHP is different to Go. So obviously with PHP, you must have PHP installed on the server, and then if you are making a web app, you need the server itself because you need the PHP interpreter. You need something to interpret the code because it's an interpreted language. And then with Go, because it's a compiled language, the only thing you have to make sure is that you compile it for the right architecture, because obviously it's the same as C. Like if you compile it on a Mac, it might not work on CentOS or something. So compile it for the right architecture, and then you just run the binary. And that's as simple as that. You don't even need Go installed on your production box if you run Go in production, because it's just a binary. Some examples for applications and use cases. With PHP, we typically do web pages, APIs. We do command line apps. Some people use it for like Bash scripts where they don't want to write Bash, so they write a PHP script and to do stuff. With Go, we can do all of this plus pretty much like a lot more, and anything else, anything under the sun. Like we can do services, you can do backend components, you can do infrastructure components, you can write load balancers or proxies or servers in Go. So everything that PHP can do and much more. So Go is kind of like a box of Lego basics where like you just get the bricks, and it takes a little bit of work to work out what you're doing, but in the end you can just build whatever the hell you want. And then when I was writing these slides, I was like, ooh, what if we, could we serve PHP with Go? Because I was saying that you can do pretty much anything. Well, turns out you can't quite do that yet, because like even though Go supports the net HTTP package, supports fast CGI, it only supports the receiver side of things, not the sending thing. So you can't quite do it with fast CGI. So you would have to serve PHP with CGI, which is slow, and you don't want to do that. So can't quite do that yet, but I thought, maybe one day. I don't even know why you would want to do it, because Nginx and Apache are pretty solid, but hey. And then looking at benchmarks, like I'm always like, you always have to take these with a pinch of salt, because like it depends on like what somebody did and what machine they ran it on and all of that. But this is just an example test that I found on the internet. It's just a simple Hello World app, and you can see that Go did over 4,500 requests per second. And compare that to vanilla PHP, which is the third thing from the left, which is 1,000, like just under 2,000 requests. So Go came out twice as fast as vanilla PHP here, which, to be honest, is not that surprising, because it is a compiled language. It's just by definition going to be a bit faster than interpreted PHP. Just to give you a comparison, Nginx came at like almost 18,000 requests per second, serving just static files. So Nginx is still a lot faster. But a lot of these benchmarks basically show and conclude that Go is faster than PHP. From personal experience, I also noticed that. It just feels so blazing fast compared to that. So yeah, if you were looking for something slightly faster than PHP, especially if you're not necessarily building a web interface of any kind, then Go might be something that you want to look into. And then a little bit about tooling, and I think that's what actually makes Go stand out from other languages, and actually makes it better than some of the other languages, is that everything comes out of the box with Go. So when you install Go, you get the formatter, you get a bunch of things, you get the compiler, and you even get things like testing frameworks, code coverage, benchmark testing. All of that comes with the standard Go installation. So compare that to PHP, where if you want a linter, you need to install mess detector and lint, and you need to install PHP unit. All of that, you need to do it separately. With Go, it's just as easy as running Go tests, whatever, and it's all baked in. So the setup is a lot easier, and you kind of have no excuse not to do unit tests or anything, because it's just right there. It's just built in. So yeah, you get a whole bunch of tools with Go, and then most IDEs are now configured to basically just run all of these automatically for you. So it's pretty easy. And then the sort of final thing that I wanted to touch on, like compared to two, is the community. Like I just love that photo. I think it's Bulgaria PHP because I recognize the Mario things. So yeah, that's James in the background. It's a shame he's not here doing his usual thing. And then I think it's Jeremy Mikola with, yeah, if you were at the PHP Southwest in December, you would have known how to play, well, you would have had a chance to play GeoPHPRD, which I can't pronounce. Yeah, I think the PHP community rocks, and I think it's definitely more mature than, it's been around for longer than the Go community, so obviously it's going to be a bit more widespread. There are so many conferences and meetups for PHP right now that it's probably not possible to go all of them in a year. It's just too many. I think the PHP docs are quite good. I've never personally had a problem with them. There is a ton of support online as well. But the Go community is kind of quickly catching up. There are a few bigger conferences now organized. There's Golang UK, which is in London, and then there is Gotham Go, which is in New York, and there is one in India, one in China. There is Go.dot in Paris as well. So there are a few bigger conferences that are now sort of 2-3 years old. There are a few meetups popping up as well, like even in the Southwest. I think we've had 3 pop up last year. There's one in Cardiff and 2 in Bristol. So it is kind of catching up. The Go docs are excellent. Like they are one of the best docs I've ever seen. Go also kind of comes with something called Go Playground, which is basically like you can run code online and just try it out online. And that is integrated with the docs. So when you read the Go docs and you read about a function, it will have an example that you can just run straight away, and you can tweak it and run again and see what it does. So it's a really great way to learn the language and try out something quickly. So that's a really strong side of Go, I think. So just to sum up, I don't this was never meant to be a one language is better than the other. I think neither is better. I think they're just very, very different. They're just 2 different tools that you can use to make your computer work. I did put a couple of things that I think could be better. So this is kind of like what one language maybe could learn from another. What I don't like in PHP so much, now that I've done Go for a bit, is the sort of inconsistency. And that's the things that we all know. So it's like the needle or haystack or needle, or does it have an underscore in the name? So PHP is obviously, because it's been evolving over more years, and from a functional language to an object-oriented language, and through so many iterations, it's just a little bit more inconsistent than Go. PHP allows you to do stupid things, especially being loosely typed. You can just abuse that in really bad ways, and you can leave dead code around. PHP won't really detect it because it's not precompiled. It won't care if you have a bunch of leftover code or variables. Whereas with Go, you cannot leave that code. It won't compile if you have unused variables or any bits of code that are not used, which kind of really annoys you to start with, because if you're starting to write something, then whatever you wrote but you didn't finish yet, you have to comment it out, and it just drives you nuts. But in the long run, it does teach you to basically just clean up after yourself and not leave anything that is dead, which I think is really good. PHP feels a little bit verbose to me now, with the whole public-private and function instead of func and semicolons, but that's just personal preference. Go generally tends to use, Go code tends to use less characters, I think. So, and then what I really miss in PHP now that I've been doing Go is multiple return values. This is brilliant in Go, and it's come in handy so many times. So I know that PHP is kind of maybe toying with the idea of introducing those at some point. So fingers crossed, maybe. But I really do like them. In Go. In Go, on the other hand, you can't do polymorphism, which is a shame, because you have to get better at inventing names, which we all know is hard. And the 2 things that I find myself asking quite a lot of times is, the first one is because PHP is a mature language, it's got a lot of matured frameworks and libraries that have been around for years. They've had a lot of bug fixes put in them, and it's sort of the default things that you go to if you need to solve problem A or B or C. Whereas with Go, because it's still relatively new, there are a lot of frameworks out there, but very few of them are actually mature and over version 1. So I've tried 5 different logging libraries and 3 different dependency managers, and neither of them is great. They all somehow work, but they all feel like work in progress. Neither of them is above version 1. So sometimes this can be very frustrating when you don't have a tried and tested solution in Go, and you just have to play around with stuff. And then the second one is, because it's kind of a trade-off, because Go is the core library is kept small for performance reasons and to kind of keep the language generic. It's not tailored for any particular use case. that comes at the expense of you sometimes have to write a lot of the stuff yourself, like array manipulations or something like that you normally just call a function in PHP to do something clever with an array. Chances are you will have to implement that in Go yourself. So it's a bit of a trade-off. And then this was kind of interesting to think about because like what changed in my sort of coding now that I've been in Go and then I keep coming back to PHP, I definitely did start doing things that I didn't do before, and that's thanks to Go and Go's influence. Like I started paying attention to naming. Like Go is really picky about naming, and they really sort of put an emphasis of like use very short but descriptive names. So what I would do before is like have namespace controllers and class homepage controller. And then Go would go, hang on a minute, it's in a namespace controller, so you know it's a controller, so just name it class homepage, right? It's kind of obvious, but Go really enforces this with packages and stuff, like to the point where the linter will complain and will issue a warning if you do something like that. Error checking as well with Go, the sort of idiomatic Go way is always check for the error first, because you can have multiple return values. If one of them is an error, you just always check for that first. If there is an error returned, you just discard everything else and you deal with the error, which I think is a really, really good strategy to deal with errors in general. So I try to do that in PHP now, just work around the whole multiple return values things. But generally sort of fail faster is, I think, a better approach. And keeping things simple and clean. Like Go really forces you to keep things simple, which is quite complicated. Like simplicity is complicated. So it's just a good training every day for like how to keep things simple, how to make your code easy to reason about. Keeping functions small, keeping files small, and nice and easy to unit test. Like that's something that the Go definitely trains you in. So yeah, I think that by learning Go, I became a better PHP programmer. Funny enough. Obviously, like I think that's why it's really important to know more than one programming language. Like when you're starting out as a developer, yeah, it's fine. Like carry on with your one language, but by learning more, you just gain. You just have more than one worldview, and you just gain more ideas for how to solve the same problem in different ways, which can be quite eye-opening. You can spot faster solutions. You can share ideas across languages. Like I don't know, PHP has Composer, and that was inspired by Bundler from Ruby. So it's kind of a good thing that one language can pick up good ideas from another. Goes without saying that you're more employable if you know more than one language. And it's just another tool under your belt. So you can just pick a better tool for whatever job comes your way next. This is a list of the first 3 links here are talks that I think are really, really good, whether you are interested in Go or not. They are more about sort of programming aspects than Go specifically. First 2 are by Rob Pike, and they're really good. Concurrency is not parallelism is the one that I mentioned earlier. And the second one is simplicity is complicated, which again is good for whether you do Go or not. The third one is a talk by Liz Rice, and I think she did it at Golang UK in 2015. And she does a live demo of building a simple container in Go. So it's like a Docker-style container in Go, which is really, really interesting, and it's fairly short. So that's a really good one to watch as well. And then if you do want to give Go a go, which is just a pun you cannot resist, the 4 links. The first one is just the Golang.org official website, which has all the docs. There is something called tour.golang.org, which is a nice introduction into the language. Blog golang.org. Go actually runs a blog where they explain a lot of the reasoning behind the design decisions they made, and that's actually really interesting to read as well, because sometimes you write Go and you go, why did you do it in this way? It's so stupid. And then you go off and read the blog article about it and go, yeah, I see your point. That was a better decision. So it's kind of interesting to find out about that from the blog. And then the last one is Go by Example, which is just another website which gives you examples for all the different aspects of Go, and it's just like a nice and easy introduction. And that is it for me. So thank you so much for listening. There is a joined in link if you want to give me feedback. And if you have any questions, you can shout them now, or you can catch me in the pub, or you can tweet at me, or something like that. So yeah. We actually may be just writing code. Well, we do argue about design patterns because it's quite because Go is kind of still fairly new. There is a few different design patterns. Like DDD is really taking off in the Go community now. So everybody's now doing DDD, but that's quite recent. So Go doesn't really specify how you should structure your apps. It only specifies where your app needs to live on a disk, which pisses some people off. It doesn't piss off me, but because in PHP you can have your code anywhere on the disk, and you just point your document root wherever the code lives, and that's fine. With Go, you have to specify something called Go path, and that defines where all your Go code lives. And then you have to sort of, the directory structure is basically a vendored name of your package to keep the whole thing unique. And that's kind of how Go needs to be structured on your disk, the Go way. Some people just get annoyed with this and then repoint the Go path into other places. But that's kind of that's only where you put your code. Whereas how you structure your package is completely up to you. Like Go doesn't really specify any, like they have some guidelines, but it's not like you have to do this and this and this and that. So it's kind of the same as PHP. So it's the same as in PHP. You have the MVC way of structuring your app, or you can do DDD, or you can do all sorts of things. It's the same with Go. So most of the discussions I've had was kind of where do we put things, how you break up your app into packages, because that's quite tricky sometimes as well. Like if it's the sort of code reusability versus keeping packages separate and like sort of making them more like a drop-in style package. So yeah, probably design patterns I would say is the I've had hour-long discussions with some people about like how to do that. But you know, it's much nicer I think than like arguing about tabs versus spaces. Yeah. Yeah, come on.
So you said there's no standard Go package manager?
No, the rumor has it that it was meant to ship in 1.8. Now they said it will come out in 1.9. So we're still kind of all waiting because there is a few solutions out. It's really surprising because the amount of tooling that Go comes with, you would expect a dependency manager to be there. There isn't anything. And the most popular ones are Glide, GoDep, and the one I cannot remember right now. There is a bunch of, like people just have gone out and wrote their own things. It's mostly composer inspired. But there isn't an official one, so we're still waiting for that because none of the three are actually above version 1 or work great. So, yeah. It's quite surprising, but I think they're working on it. It's one of the things that, like, I think enough people shouted about it, like, give us a dependency manager that works, and I think, it will happen soon.
One serious question. You said in there about you have to check the errors, so they don't have exceptions.
No, there is one type called error, which is kind of your exception in PHP. Like I think don't they inherit now the throwable interface errors and exceptions, yeah. So there's only one type called error, which if you think about it, it's genius because it's simple. Like error or exception, same thing, right? Something went wrong.
So you see there's checking things like dead code and such.
Yeah.
Does it also check if you ignore potential errors?
It won't compile if you. So when you call a function, you have to assign. So depending on how many things that function returns, you have to sort of assign those return values to variables. So you can you can cheat and do underscore, which means I don't care what this value is. I'm not going to use it later on, but you still have to acknowledge that it's going to come back. And then, so if you accept like value and an error, it doesn't force you to check it. But if you don't check it, then error becomes an unused variable. So you highlight that you have an unused error variable. So you should do something about it. So it indirectly prompts you to
so
that.
You call your error?
It can be called anything. It would just basically say that, yeah. If you put an underscore, it will know that you don't care about this. And sometimes, very, very rarely, you might find yourself doing that for errors as well, because you're already like sort of returning a different thing, or like I don't know. But I've come across it like once, maybe twice in the last year that I've had to do it. So, yeah.
Thanks very much.
Thank you.